This is exam 4b, physics 101. Which will experience a bigger buoyant force when in water? 100 kilograms of ice or 100 kilograms of wood? All right, so what's key here? I give you the densities, and of course, the density of ice is equal to 917 kilograms per cubic meter. But that's not really relevant here because what's relevant is that I have a buoyant force and pushing up. And because both of these have a density less than that of water, that buoyant force will equal to the weight. So since I have 100 kilograms of each, they're going to be both the same. Two beakers are filled to the brim with water. A block is placed in beaker B and sinks to the bottom. Both beakers are weighed, then which scale reads a larger weight? Okay, so the answer here is B. Beaker B has a larger weight. And that's because of the water that this displaces. This block displaces its own volume in water. And so if I have the steel block, this is steel, it displaces an identical volume of water. And of course, since water has a lower density than steel, then the steel will contribute more to the weight. So I basically replaced the water that was right here with steel. Steel has a bigger density, so the beaker is now going to be heavier. By the way, that's different, of course, as we've seen in some of our problems where if it's floating, then they would have the same weight, both beakers A and B. Solid rock suspended in air by a spring scale has a measured mass of 9 kilograms. When the rock is submerged in water, the scale reads 5 kilograms. What is the volume of the rock? So what's relevant here is that I have a force that's acting on this that that makes it appear 4 kilograms lighter. So 4 kilograms times g will give me my force. So I have a force of 40 newtons. That is that I have this object is suspended such that it reads that it's just 50 newtons in weight. But I know really, that's what the scale reads. I know really that my weight is 90 newtons because it's 9 kilograms. That means that I have this extra 40 newtons, and that is my buoyant force. So the buoyant force is equal to 40 newtons. Now I want to know what is the volume of the rock. So I say FB equals rho VG. That's 40 newtons is equal to 1,000. That's the density of water times the volume. That's what I want to know, times 10. And so it's 40 over 10,000. All right, yeah. So that goes away. Move that decimal place. 0.004. So A is the right answer. Two blocks of ice float in water as shown. And what's important is that they're identical blocks of ice. So that means that they have the same mass. So in each of these, my weight will be the same. And in each of them, since they're floating, the buoyant force will equal to the weight. So it doesn't matter that they're oriented differently. The amount of volume that is submerged will be the same in both. So E is the right answer. Water flows through a pipe as shown. Where is the pressure greatest? So the pressure is greatest where the velocity is lowest. So if the velocity is low, that means that the pressure is big. And I have the lower velocity right here, so A. By the way, that's continuity equation, right? If this is A1, if this is V1, this is A2, and then the velocity in that section of the pipe. I know from the continuity equation that A1 V1 equals A2 V2. So if A2 goes down, that means V2 goes up. So it's slow here and fast here. And then this is the Bernoulli principle. It's an application of the Bernoulli's principle. That is that if the velocity decreases, the pressure increases, and vice versa. If the velocity goes up, the pressure goes down. Okay, so the same. I have an ideal fluid flowing through this pipe. The cross-sectional area of this section is 1.2 square meters, and then the speed is 3.2 meters per second. And then over here, my cross-sectional area is half, or 0.6 meters squared, and I want to know what the speed is. Now I know from what I said earlier that the speed in this section is going to be bigger, so I get rid of that. I'll get rid of them all. So 6.4 has to be the answer. But let's just go through this. A1 V1 equals A2 V2. That is 1.2 times 3.2 is equal to 0.6 times V2, and so V2 is equal to 6.4 meters per second. Oh, consider this pipe as water flows through it. The cross-sectional area is 1.2. Okay, same as we had before, except now I'm giving you the pressure. So the pressure here is 32,000 pascals. The velocity is 3.2 meters per second. And now you know that the velocity over here is twice that, or 6.4 meters per second. And I want to know what is this pressure. I'm going to call this P2, V2, V1, P1. I do want you to notice that the height of this is not changing, so that part of the Bernoulli principle where we deal with height, we're just going to leave out. So I have P1 plus 1/2 rho V1 squared equals P2 plus 1/2 rho V2 squared. 32,000. That's equal to P2. Right, and if I solve that for P2, pause here for just a second while I do that in my calculator. Let's see, so I get 37,120 on this side, minus 1/2 of 1,000 times 6.4 squared. Minus 2480. Keeping too many sig figs right now, but let's see. I get 16,640, or if I'd rounded differently, but the answer then is C. All right, when an artery becomes clogged, which of these statements describes the flow of blood through the clogged artery? Well, so if I have an artery and I get a blockage right here, then I know that this blood flow is going to go faster right here. And if the velocity goes up, I know that the pressure will go down. So the velocity increases and the pressure decreases. So that this, as we talked about before, this can lead to arterial collapse because you get such a low pressure inside of that artery. Um, the pressures on the outside of the artery will just cause it to collapse. How many cubic meters of water and 300 kilograms of water? Well, I know that the density of water, of the liquid, is 1,000 kilograms per cubic meter. So if I have, a third, then I'm going to have a third of a cubic meter. But like I say, this density is mass over volume, and so volume is mass over density, or 300 over 1,000. That's equal to 0.3. So A is the right answer. Piece of aluminum has density, 2.7 grams per cubic centimeter. Notice I'm using CGS here, and a mass of 775. It's submerged in a container of oil, and I give you the oil's density. How much oil does the metal displace? Okay, so this seems a little bit complicated, but it turns out that this, or rather that the whole oil density doesn't really matter. It doesn't really matter what it's in. The fact is that if this block of aluminum is in a container, it's going to displace its own volume. So really this is the same as what we were doing before, where the volume is the mass over the density. And so that's going to be the mass, which is 775 over 2.7. Just double check my units there. They cancel out, so that's right. So I have 775, 287. So right there. For number 10, which fills a larger volume, 100 kilograms of gold or 100 kilograms of lead? All right, well, you want to know which one has the less density, and so the one with less density is the lead that's on your equation sheet, has the lower density, and because it has a lower density, it just takes up more space, right? Density is mass over volume, so volume is mass over density. If this goes down, this goes up. Following this diagram for hydraulic jack, area on the piston over here is A1. So here I have A1 and here I have 4A1. My piston is getting 4 times as big. Here I have 40 newtons. What is my force on this side? Well, you probably know this. It's going to be 160, right? But because my area is increased by 4, my force has as well. But I can say that F1 over A1 equals F2 over A2. So that's going to be 40 divided by A is equal to F over 4A. The A's cancel, and F is equal to 160 newtons. Pascal's principle is right here. This is, again, Pascal's principle. The mercury barometer at atmospheric pressure, the height of the column of mercury in a glass tube is 760 millimeters. If you replace the mercury with glycerin, what will the height of the column be? So here, the density of mercury is actually quite a bit more than the density of glycerin. And so if I put this barometer with glycerin, because P is equal to rho GH, if rho goes down, that means H has to go up. So C. Okay, so here I'm imagining right here that I have this column of air sitting on top of me, and I want to know what is the height of this air. What is H in order to give me this atmospheric pressure? So P is equal to rho GH. Or P naught is 0 here because if you imagine that I have space up here, there is no pressure pushing down. So it's going to be 100,000 is equal to 1.29. That's my density times 10 times H. So H is equal to 7,800. I consider this manometer. What describes this relationship? Well, because this level is lower, this pressure is bigger. So P is bigger than P naught. It's like you imagine it pushes down harder than it does over here. Okay, same manometer, right, the same situation. What is the pressure P? So I really need to put this into practice. P is equal to P naught plus rho GH plus or minus. I need to figure out, is this going to be a plus or a minus? Well, since P is bigger than P naught, it's going to be plus, so I'll get rid of that minus. That's going to be 1 atmosphere, 1 times 10 to the 5th, plus, this is mercury. You can look on your equation sheet. It's 13,600 times G times 0.1. And so that is, the G and 0.1 just go away. That's equal to 1, right? 10 times 0.1 is 1. And so this is 113,600, or 1.1 atmospheres. Because remember, 1 atmosphere is 100,000 pascals. And so this is in pascals, I would have 100,000 atmospheres there, and give me 1.1. All fluids are there. Anything that flows. What is proportionality constituting stress and strain? That would be Young's modulus. Stress is expressed in terms of which fundamental quantities. Ooh. So stress, if you recall, F over A is Y delta L over L. This is my stress, this is my strain. And so stress is a Newton, that's a kilogram, meter per second squared, over area, meter squared. So I get this cancels with one of those, and I'm left with D. How large a force is necessary to stretch a 0.2 centimeter steel wire by 1/100th of its original length? All right, so not easy. So I have F over A equals Y delta L over L. So F over A, or I'm looking for F, so it's going to be equal to A Y delta L over L. Now, this delta L over L, uh, delta L is 1/100th, so I can say 1/100th of L. And so that's going to be equal to 0.001. All right, so I can have this is AY times 0.01. And so the F, oh, and then so now the area is going to be pi r squared, pi times zero point 0.1 centimeters or 0.001 meters, pi r squared times y times 0.01. Give me just a second, I have to find y. It's on your equation sheet for steel. Okay, so on my equation sheet, I'm looking for Young's modulus for steel. Looks like it's 20 times 10 to the 10th. So that is pi 0.001 squared, 20 times 10 to the 10th, 0.01. I get 6280, so 6300 newtons required. This tricky one there because you had to figure out the area, and then there was this whole thing about delta L over L is actually equal to 0.01. It's looking at the ratio of delta L to L. All right, which is your favorite class? Of course, D. It's my favorite class. I don't know about y'all. And there's the answers. Notice we did have a few repeats from some of the previous semesters, so some of those questions might have looked familiar to you.